Hello everyone, welcome back to my YouTube channel Cloud and AI Analytics. Hope everyone is doing good. I am Vignesh and in this video we'll be continuing our playlist on Apache Spark interview question and answer. So I have already created one video which has around 7 questions. You can take a look at it and in this video we'll be continuing on top of it. So without any further delay, let's get started. So the first question which is very common is what distinguishes between Spark context from Spark session? How do they differ in their functions and capabilities? So this is something which is commonly asked in big data engineering interviews. So Spark session and Spark context are known to be the heart of Apache Spark. Both are the entry point to interact with Spark cluster, but they have distinct functions and capabilities. First, we will start with Spark context, then we will try to understand what is Spark session, finally the difference between those two. So Spark context, in the older version of Spark, it is used to be the entry point for any Spark job. It provides low level functionality like creating RDDs and only RDD alone. And you will be able to manage the cluster resources and distributing the task across the nodes. So all those things will be taken care by Spark context as well. And it doesn't support high level features for data frame and data set. And you will be not able to see any inbuilt support for Hive or SQL, and there are lack of automatic management resource ability. So and next the Spark session came into the picture. So it is an unified entry point for interacting with Spark. When I say what is unified, it because it supports RDD, data frame, dataset, SQL, queries, Hive, and built-in optimization. It acts as an umbrella. So everything will come under this Spark session itself, and it is supported in the latest version of Spark. Spark session optimizes the execution plan for queries and help us it making it more efficient. And Spark session provides a single interface for working with various Spark features that includes Spark SQL, data frame, dataset, and streaming APIs. And also it supports reading and writing data in various formats, executing SQL queries, and performing various data processing tasks. Finally, Spark session provides optimization as well, like query optimization, catalyst optimizer, and code generation. Even though the optimization are done manually in Mark, Spark session support it, whereas Spark context does it. So the next question is, what is the difference between cache and persistence in Apache Spark? So first we'll try to understand what is cache and persistence in Apache Spark. Spark provides an optimization mechanism to store the intermediate computation of RDD, data frame, and dataset. So both cache and persist is an optimization mechanism to store the intermediate computation of an RDD, that is resilient distributed dataset, data frame, and dataset. So they can be reused in subsequent actions. So it means like we will be reusing the RDD, data frame, and data sets with their computation results. So both caching and persist are used to save the Spark RDD, data frame, and dataset. First thing, we'll understand what is cache and what is persist. So cache, you can store only the data in memory, while with the persist you have more flexibility. When the data size exceeds, you will be able to save it in memory as well as you will be able to save it in disk. Also with persist, you can store the data in serialized format. So with persist, you can have different storage level like memory only, memory and disk, memory only sir, memory and disk and disk only. With cache, we have only one option, that is the default storage level, that is memory only. So you can see what is memory only, memory and disk, all these things in this particular image. You can pause the video here and take a look at it. So the next thing is, what are the advantages for caching and persistence? So basically cache and persist is mainly used to do for cost, saving the time, and also it saves the execution time. You can pause the video here and take a look at this as well. So now we'll see what is the difference between partition and collapse. So partitioning of an existing RDD or data frame can be changed using repartition or collapse. So basically both repartition and collapse will help us to do the partitioning of an existing RDD or data frame. These operations can distribute the RDD data frame based on the number of partitions provided. First, we will try to understand what is repartition, followed by collapse. So repartition is used to increase or decrease the RDD data frame partitions. Repartition is an entire shuffle operation. So when you do repartition on an existing data frame, it will either increase or decrease the data frame partitions, and obviously it involves lot of shuffling operations as well. So whole data is taken out from an existing partitions and equally distributed into newly formed partitions. And where to use this partition? repartition. If you have a loaded data set that includes enormous data and many transformations that need an equal distribution of executors, you need to use repartition. So when you have enormous, very huge volume of the data and you have to do many transformations in that particular data set, then there is a need of distribution of executors. In that case, you have to do the repartition. The next one is Quelas. So Quelas is only used to only decrease the number of partitions in an efficient way. So Quelas avoids complete shuffling, whereas repartition, it does the complete shuffling. Instead of creating a new partition, it shuffles the data using hash partitioner and adjusts into an existing partitions. So when there is an already a partition done, when we are using Quelas, it will not do or it will not increase the partition. What it will actually do is it will create or it will decrease the partitions. So when to use this Quelas? So once all the transformations are applied, so in the existing data set or in the existing RDD data frame, once the transformation is completely applied, then we can use the Quelas to save all the data in a fewer files. So here I have given the difference between repartition and Quelas. Repartition offers more capabilities compared to Quelas, and in Quelas, when it comes to reducing the partitions, Quelas is more efficient than repartition. So repartition can increase or decrease the partitions, whereas Quelas, it will only decrease the partition. And in repartition, we do not worry about the amount of shuffling because the shuffling operation will be huge and it will consume a lot of memory and power. And it is basically slower than Quelas, whereas Quelas, it tries to avoid shuffling. The next thing is what, according to you, is the common mistake Apache Spark developers make when using Spark. So there are very common mistakes that people make while writing a Spark application. This is a very basic question asked in the Spark interview. So the first thing is forgetting to catch in general. So they basically forget or tend to forget the catch in general, or they will be not using the catch when required or at the proper places, or else they will be using catch at every time, which makes it work very fast. Not parallelizing the data properly or using the resources provided to you properly. And the next one is not writing proper optimized SQL queries or using the inbuilt functions which is provided by Apache Spark. And another common mistake made by Apache Spark developers, they tend to convert this into pandas data frame and vice versa. So this is very commonly made mistake across the Spark developers. And then using collect function whenever it is not required, and using show function also whenever it is not required. And then this is also a common mistake made by Spark developers. They tend to use wrong data types in data frame and not using them properly. So the next thing, what are the disadvantages of using Apache Spark? So the first one is no file management system. So Spark, it has no management file system of its own. It does not come with its own management file system. It generally depends on SDFS. So Hadoop distributed file system is what Spark is also dependent on. The next one is no support for real-time processing. So actually Spark supports real-time processing. It does not support completely. So by Spark streaming, the live data which arrives is automatically divided into batches. Those batches are of the predefined interval. Then each of the batch of data is handled as Spark RDDs. So there is no real-time support for Spark streaming. And the next one is small file issues. So this issue, it's been with the Hadoop as well. The same thing, since we are using SDFS, the same thing is applicable to Apache Spark as well. The next one is cost effective. Since Spark works in memory, it is basically more costly than Hadoop system. While we talk about cost efficient processing of big data, keeping data in memory is not easy. At the time we worked with Spark, the memory consumption was very high. Spark requires huge RAM to process in memory. So that is what, it is not that efficient while it comes with cost. So the next one is window criteria. As we discussed that Spark doesn't support real-time applications, the same goes with this Windows criteria point as well. So the next one is latency. Apache Spark has higher latency and lower throughput. When you compare it with Apache Flink, Apache Spark has higher latency and low throughput. And the next one is less number of algorithms. If you want to work in machine learning using Spark, there is a very limited number of algorithms are supported currently. So these are some disadvantages with Apache Spark. And the next question is, what are the different ways to create a data frame, Spark data frame? After initializing the Spark session, you can use create data frame method to create a Spark data frame, or you can use 2DF method to create a Spark data from RDD list and the pandas data frame as well. So you can also create PySpark data frame from data sources like file, CSV file, JSON file, ORB file, Avro file, Parquet file, and XML files. And also if you read data from sources like SGFS, S3, DBFS, cloud storage. So here you can see in this image the Spark session like create data frame RDD, data list, row data on columns, data list and schema. And if it is an RDD, you can use this DF and DF columns. And if it is a data frame also, you can use 2DF and whatever the columns you wanted there. So these are some various or many ways to create a Spark data frame. So the next question is explain the file formats in Spark. So basically Apache Spark supports various file formats like Parquet, JSON, CSV, SQL, NoSQL data sources and plain text files. So Parquet is the very commonly used or it is native to Apache Spark. And the next one is you can see the image here and whatever the properties and whatever it is supported in the respective file formats like columnar, compressible, splittable, readable, complex data structure and schema evolution. So if you see like Parquet almost checks all of that. So that's it for this video. I hope you learned something new from this video. If you have any questions, please post that in the comment section. I'll take a look at it and reply to it as soon as possible. Please do like, comment, share and subscribe to Cloud and AI Analytics and don't forget to click on the bell icon. In upcoming videos, I'll be uploading more questions, more live codings also in this particular playlist. I'll see you there. Happy learning.